Definitions on space and vacuum under the scope of the modern physics. The term vacuum for the spaceship's designers. The most important consideration for spaceships designers concerning the definition of space vacuum is that the concept of vacuum is related as a subset of orders and magnitude values upon specific velocities. Dependent on the speed of the spaceship, the overall external surface area is affected by transitional effects upon vacuum transitional states. Keep in mind that these transitional effects occurred in several scales of magnitude affecting subatomic, atomic, crystal and surfaces structures that have to simultaneously and timely compile to the time unit reference frame of the observer in order to control issues for propulsion and navigation. While conditions of vacuum is almost instantly lethal for a human entity more than up to 39 seconds with rapid pressure room loss to the interior compartments, these very same conditions on vacuum can be used as instant isolation conditions to protect critical infrastructure's compartments from exceeded rapid heat, fire hazards, structural osmosis and internal atmospheric contamination. The term vacuum for the spaceship's designers. In modern particle physics, the vacuum state is considered the ground state of matter. The strictest criteria to define a vacuum is a region of space and time, where all the components of the stress-energy tensor are zero. But we already acknowledge that zero definition to this extent of space vacuum prescription has limitation due measurement criteria of absolute value definition of zero, as we already have learned from the initial video lecture of this week and especially due relativistic co-moving reference platforms near the speed of light velocities. In a more open consideration discussion for the vacuum term, if we consider vacuum as a uniform quality state of the term emptiness, then the vacuum state cannot consider as a ground state of matter, as the modern particle physics has addressed above. Also the case of paraproduction, that is the inverse condition of annihilation, where we can produce matter from energy, the whole process is quantified rather qualitized. In terms of emptiness, because we still use matter-energy ratios and not qualified states of emptiness, as the concept of vacuum emptiness has defined. This statement is clearly descriptive for the subatomic and atomic scales. The term vacuum for the spaceship's designers. For incremental scale for the free vacuum measurements, especially for the electromagnetic effects, the geometric projection of a tensor is used in order to extract meaningful effects in relation of vacuum of free space and not the term vacuum as definition alone. The vacuum of free space, or sometimes just free space or perfect vacuum, is a standard reference medium for electromagnetic effects. Some authors refer to this reference medium as classical vacuum, a terminology intended to separate this concept from QED vacuum or QCD vacuum, where vacuum fluctuations can produce transient virtual particle densities and a relative permittivity and relative permeability that are not identically unity. In general, for even more larger scales, if all matter could be removed from a volume, it would still not be empty due to vacuum fluctuations, dark energy, transiting gamma dash and cosmic rays, neutrinos, along with other phenomena in quantum physics. It means that this region is empty of energy and momentum, and by consequence, it must be empty of particles and other physical fields, such as electromagnetism, that contain energy and momentum. In general relativity, a vanishing stress-energy tensor implies, through Einstein field equations, the vanishing of all the components of the Ricci tensor. For the free space properties with electromagnetic characteristic and conditions, electromagnetic radiation travels, when it is unobstructed, at the speed of light. However, speed of light could travel in lower speed. Inside materials properties characteristics affecting the structural installation designs whenever it is needed, as for examples for measurements techniques for navigation or structural vacuum sensing installations or on various concepts of radiation shielding. Manipulation of the speed of light upon such layers of designs that are based on the same reference platform of a spaceship is a crucial factor for the structural integrity functionality that should be always related with the free space vacuum conditions. Important considerations relative to the free space conditions are, permittivity, apermeability, are exactly the electric constant zero and magnetic constant zero, respectively in C units, or exactly 1 in Gaussian units. the characteristic impedance equals the impedance of free space equal and approximate to 376.73 hm. For the free space properties with electromagnetic characteristic and conditions, the vacuum of classical electromagnetism can be viewed as an idealized electromagnetic medium with the constitutive relations in C units, relating the electric displacement field D to the electric field E and the magnetic field or H field H to the magnetic induction or B field. Here R is a spatial location and T is time. In large-scale travel distances, concerning the free space vacuum conditions, electromagnetic characteristics can be altered due vacuum fluctuations, where quantum physics play a significant computation role, as we recently found now to the world of astrophysics. For the free space properties with electromagnetic characteristic and conditions, for the ampere, as a fixed number of elementary charges per second, the electric constant would not have an exact fixed value. The value of the electron charge would become a defined number, not measured. Consequently, vacuum permittivity also would not be exact. As before, it would be defined by the equation, but now with a measurement error related to the magnetic constant. This measurement error can be related to in the fine structure constant also for navigation correlations, with E the exact elementary charge, H the exact Planck constant, and C the exact speed of light in vacuum. And the relation with the fine structure constant is. For the free space vacuum properties with electromagnetic characteristic and conditions, space vacuum types can characterized by the electromagnetic fields, particles densities and selected permittivity ratios and plasma flows. The term vacuum for quantum electrodynamics and astrophysics. In QED vacuum, the electric and magnetic fields have zero average values, but their variances are not zero. As a result, QED vacuum contains vacuum fluctuations virtual particles, that hop into and out of existence, and a finite energy called vacuum energy. Some experimentally verified effects of vacuum fluctuations include spontaneous emission and the Lamb shift. Coulomb's law and the electric potential in vacuum near an electric charge are modified. These are important energy fields architecture's relations for energy compartment considerations as well. QCD vacuum multiple vacuum states can coexist. The starting and ending of cosmological inflation is though time, to have arisen from transitions between different vacuum states. For theories obtained by quantization of a classical theory, each stationary point of the energy in the configuration space gives rise to a single vacuum. String theory is believed to have a huge number of vacua, the so-called string theory landscape. Radial tensors definitions that can affect free space vacuum conditions. Formation stages that affect the free space vacuum conditions with transformation of a radial tensor. This concept is useful also for navigation issues for radial or turn trajectories. The most important consideration for spaceships designers concerning the definition of space vacuum is that the concept of vacuum is related as a subset of orders and magnitude values upon specific velocities. In a more open consideration discussion for the vacuum term, if we consider vacuum as a uniform quality state of the term emptiness, then the vacuum state cannot consider as a ground state of matter. For incremental scale for the free vacuum measurements, especially for the electromagnetic effects, the geometric projection of a tensor is used in order to extract meaningful effects in relation of vacuum of free space and not the term vacuum as definition alone. In large-scale travel distances, concerning the free space vacuum conditions, electromagnetic characteristics can be altered due vacuum fluctuations, where quantum physics play a significant computation role, as we recently found now to the world of astrophysics. In QED vacuum, the electric and magnetic fields have zero average values, but their variances are not zero. As a result, QED vacuum contains vacuum fluctuations virtual particles, that hop into and out of existence, and a finite energy called vacuum energy.